Hey everyone, and welcome. Today, we're going to tackle a really important topic in telecom, especially for you software testers out there, Operations Support Systems, or OSS for short. We're going to break it all down and show you why this system, which might seem a little bit behind the scenes, actually matters to your daily work way more than you probably think. Let's get into it.
So I'm willing to bet that if you're a tester, this thought has crossed your mind at least once, right? I don't really test OSS. It's not even part of my application. And you know what? That's a totally normal reaction. Your focus is on your app, your features, the user interface. Why would you need to worry about some other system that the ops team uses?
Well, here's the thing. In the world of telecom, making that assumption can be, well, a little dangerous. It can quietly lead you down the wrong path when you're troubleshooting. Because even if you never, ever log into an OSS screen, its behavior is constantly, silently influencing the stability and the quality of the exact systems you're testing, day in and day out.
Okay, so let's get right to it. What is OSS really? We're going to unpack this with a really powerful and, I think, simple analogy that makes it all click.
So at its very core, OSS, or Operation Support Systems, is basically the collection of software and hardware that does all the heavy lifting of monitoring, managing, and controlling the entire telecom network and all the services running on it. You can think of it as the mission control, the command center for the whole operation.
And this right here is the key analogy that's going to make everything make sense. If you think of the network itself, all the cables, towers, and servers as the human body, then the OSS is its nervous system. It's the part that's constantly feeling, sensing what's going on, interpreting those signals, and then reacting. It tells the operators, hey, everything's good over here, or whoa, we have a problem in this area that needs your attention right now. So the OSS basically has four main jobs. First up, you've got monitoring, which is pretty self-explanatory. It's just keeping a constant eye on the network's health. Then there's fault management, which is like the network's emergency response team for when things go wrong. After that, we have performance management. This is all about measuring the quality of service to catch things like slowdowns or poor call quality. And last but not least, configuration management, which handles all the settings and parameters for the network components. And trust me, these four functions, they are the secret key to unlocking some of your most confusing bugs.
Okay, so enough with the theory. This is where the rubber meets the road for us as testers. Let's talk about how understanding OSS can actually explain some of those super frustrating real-world bugs you run into all the time.
Let's start with a classic, and I know you've been here. Have you ever seen a bug that just magically fixes itself? You see a service failing, you scramble to get all the logs and screenshots, you file the ticket, and then, poof, it's working again. It's enough to make you pull your hair out, right? Well, here's the secret. That self-healing bug probably wasn't magic. It was almost certainly the OSS fault management system doing its job. See, what you see as a flaky, intermittent failure, the OSS sees as a specific alarm. And when that alarm goes off, it can trigger an automatic healing action, like restarting a process or rerouting traffic that fixes the problem before a human even has to look at it. So here's your new move. Next time this happens, don't just close the ticket as cannot reproduce. Go to the ops team and ask them to pull the OSS alarm logs for that exact time. I bet you'll find something. All right, on to the next one. This is another one I'm sure you felt. Everything is working. All your functional tests are passing with flying colors. Nothing is technically broken, but the system is just slow, like painfully slow. And the big question is, how do you even begin to report that in a way that gets taken seriously?
This is where the OSS performance management system becomes your best friend. That vague feeling you have of slowness isn't just a feeling. It's backed up by hard data inside the OSS. The system can show you that, yep, CPU utilization is spiking during peak hours, or that network throughput has dropped significantly. It gives you the concrete why behind the slowdown. And just like that, you've turned a subjective complaint into a solid, objective, data-backed defect.
And for our final classic mystery, the dreaded "it worked yesterday" bug. You know the drill. A feature was working perfectly. Then there's a new deployment, and suddenly, it's broken. The first instinct is always to blame the code, right? But what if it's not a code bug at all?
So often, the real culprit is the configuration. That's the job of the OSS configuration management system. It's what pushes out all these changes. A bug that pops up right after a deployment could easily be because of a partial update that didn't go through all the way, or maybe a mismatched parameter between environments. Now, instead of just pointing to the latest code commit, your bug report can suggest, hey, can we also check the configuration history for this component? You're not just finding code defects anymore, you're finding configuration defects. So you can see that knowing this stuff isn't just about closing tickets faster. It's about something much bigger. It's about fundamentally changing your value as a tester and giving you a real professional edge.
Just look at the night and day difference here. On the left, you have a pretty standard, kind of vague bug report. The app is slow sometimes. It's probably going to get a medium priority and sit in the backlog. But look at the right. This is a report from an OSS-aware tester. It's precise. It's data-driven. It even points to a specific region and correlates the slowdown with resource utilization. Now, which one of those reports do you think is going to get immediate attention? This is how you provide credible, actionable information that developers and operations teams love. And that's how this knowledge completely elevates your role. You're not just a bug finder anymore. Now, you're someone who can spot systemic issues before they become huge problems. You're providing much stronger defect analysis. You're actually collaborating with the operations teams, speaking their language. And you start to gain serious credibility when people are talking about production stability. You become a key player.
Okay, so let's wrap this up. I want to boil everything we've talked about down to a few key takeaways you can start using like today. Here's what I really want you to remember. First, OSS is the network's nervous system. That's the big idea. Second, so many of your weirdest bugs, the flaky ones, the slow ones, the it worked yesterday ones, are actually explained by fault, performance, or configuration issues in the OSS. Third, and this is huge, OSS data is what helps you get from just knowing what broke to truly understanding why it broke. And finally, putting it all together, understanding OSS simply makes you a better, more effective, and more credible tester. Period.
So, I'm going to leave you with a question to take back to your work. The very next time you see one of those strange, hard-to-pin-down bugs, I want you to pause for a second. Instead of just documenting the failure, ask yourself this. What story is the OSS trying to tell me right now about the health of my system?
I really hope this helped clear things up for you. If you found this explainer helpful, please do me a huge favor and hit that like button. And be sure to subscribe to Enhanced Smart Skills for a lot more simplified telecom and testing concepts just like this. Thanks for watching.